Hello everyone, once again you're welcome to our channel. Today we shall be discussing on how to calculate the jet engine power input required. Once again, how to calculate the jet engine power input required in kilowatts. Let's read through our question we have today. A Rolls-Royce jet engine compressor has airflow inlet at 0.03 meter cube per second at 209 kilopascal in pressure. During the compressing processes, the air temperature increases from minus 4 Celsius to 412 Celsius. Now, calculate the jet engine, that is the Rolls-Royce jet engine power input required in kilowatts. Assuming that the gas constant R equals 0.287 kilopascal meters cube per kilogram per Kelvin, and the specific heat at constant pressure of air to be 1.018 kilojoule per kilogram per Kelvin. Now, let's pull out our given parameters. Our given parameters are pulled out. Our volumetric flow rate, which is V dot, which is 0.03 meter cube per second. Our inlet pressure, 209 kilopascal, being given. Our inlet temperature of the gas at the compressor, which is minus 4 Celsius plus 273, which gives us 269 Kelvin. Our temperature 2, which is the exited temperature of the compressor, which gives us 412 plus 273, which gives us 685 Kelvin. Our R, which is the gas constant, which gives us 0.287 kilopascal meter cube per kilogram per Kelvin. Our CP, which is the specific heat constant at pressure for the air, which gives us 1.018 kilojoule per kilogram per Kelvin. Now, to calculate our volumetric flow rate and specific volumetric rate, which is V, which equals RT over P. Now we have 0.287 times 269 over 209. That gives us 0.2649 meter cube per kilogram, which is the specific volumetric flow rate. Now that we have specific volumetric flow rate, now we have our M, which is the mass flow rate, equals V dot over the specific flow rate, which gives us 0.03 meter cube per second over 0.6394 meter cube per kilogram. That gives us our mass flow rate to be 0.0812 kilogram per second. Calculated. Now, to calculate the jet engine power input, now that we have found the mass flow rate of the gas passing through the compressor, using the ideal gas concept or law, we have our work, which equals the work of the compressor, which equals MRT, the natural logarithm of the variation of the pressure. Therefore, our work input of the compressor of our jet engine, which equals MCP, multiplied by the variation of the temperature, which is T2 minus T1. That gives us 0.0812 times 1.018 times 10 raised to the power 3 into bracket 689 minus 269 Kelvin. So that gives us the work input of the compressor, which gives us 34,392.64 watts. But we have to find it in kilowatts, so that gives us our work input, which is called 34.39 kilowatt calculated. Thank you.